I've featured many different components on my channel over the past few months, and they all use some form of component properties to really make them look and feel like their own custom controls inside of Power Apps. It occurred to me, however, that while we've touched on these properties in the context of the components that we've built, we haven't looked at what each of those properties really does and how you can utilize them in your own projects. In this video, we're going to take a step back and talk about component properties and their use cases so that you can have that knowledge in your toolbox the next time you're building a component. Channel members have access to download the apps used in the videos, as well as the YAML code used in the components that I showcase. You can click the join button below the video if you're interested in supporting the channel. We'll start in Power Apps and we'll head to the Components tab to insert a new component. Before we talk about properties, I do want to call out a setting that all components have called Access App Scope. The idea of scope relating to components is that components are designed to be agnostic to the app that they're used in. In a perfect world, your component would receive and send data back to your app via component properties, but you do have the option to enable App Scope, which allows the component to do things like directly patching back to a data source, or setting variables that can be used in the app, as well as other things. The best practice, if possible, is to leave this setting disabled, however, as this allows your component to be inserted into any app without needing to modify aspects of the component like data source references, variable references, or screen references. In our component settings, we see a section for custom properties with the option for creating a new custom property. When we select this, we can see that we have 4 different types of custom properties: data, function, event, and action. These are the 4 types that we're going to talk about today. Starting with the data property, this is probably the component property you've interacted with if you've used a custom property before. This allows us to either input information from the app into our specific component instance on a screen, or we can output data from our component to the app. Let's name our custom property as data input, and you can see that we're also prompted for a data type. This essentially allows us to inform our component what type of data should be input into this property. That includes basic data types like text, number, boolean, or date, as well as some other options like screens, records, or even entire tables. We'll create this example as a text data type. Now, when you create a custom property, we'll see it listed in the properties of our component. Let's go ahead and insert a text control in our component. And for the text property, we'll set this to the name of our component .data input. You can see it just says text, so where is it getting this text from? This is something that we'll see with each of our custom property types, and that's that each custom property has a default value associated with it. In this case, the default for a data input property is just text, and we can see this simply by clicking on the name of our custom property. In our formula bar, we can see our selected property is data input, and if we change the text to data input text, we can now see that our text control displays our new text. Let's take a detour to a screen in our app and we'll insert our component. We can see that it shows the data input text, and if we look over to the right, we can actually see the data input custom property with the default value of data input text. Let's insert a second of the same component on the screen, and we can see that the text still shows the same data input text. We can modify this data input text property to whatever we want, and without modifying the underlying component, we can see that the text displayed in the component changes to our new data input text. The 2 instances of the component on the screen are isolated from each other, and we're just able to pass in the information to be displayed using our custom property. This is the major function of the data input type. We're providing information to our component to then be used by the controls in the component. Let's go back to our component now, and we'll create a new custom property. We'll call this one data output, and we'll set the type as data with the output option. Now, the purpose of the output type is to feed data back to our app. This could be in many forms, but a common use case is to output the selected item from a gallery. We'll insert a gallery into our component, and this is just the sample gallery. But we can see that selecting a gallery item changes the gallery's selected item property. Let's try to output this selected item from our component to our app. We'll select the name of our data output custom property so that we can set the default value. And instead of text, we'll set this to gallery1.selected.sample heading. Now if we head back to our app, we can see that our data output doesn't show anywhere in our component properties. Instead, we can reference this property in other controls in our app by referencing our component's name followed by .dataOutput. We'll insert a text control on the screen, and for the value of this, we'll enter one of our component instances name .dataOutput. As I select different gallery items inside the component, we can see that our text updates to show the newly selected item. It's also important to note that just like our data inputs, our outputs are completely separated from other instances of the component in the app. We'll copy and paste our text control to create a copy of it, and we'll point the text property to the other instance of our component on the screen. You can see that as I click both of these galleries, each text box is updating independently from each other. So in summary, for the data type, this is probably the simplest, and you can boil it down to feeding data to your component with the input and sending data back to your app with the output. Functions are the next custom property type that we'll look at, and these are very similar to data properties in the sense that they can either be input or output, and they have a return data type, very similar to the data type of custom property. You'll see that we have a new button with functions that we didn't have with the data type, and that's to add a custom parameter. Now, parameters are dynamic inputs that can be provided to a custom property, and these then act as a parameter for the user to input when they're referencing the function. Let's start by creating a very simple function to add two numbers together. We'll call this addNumbers, and we'll set it as a function with an input property definition. For the data type, we'll set this to numbers. We're going to create two parameters in this case, and they're both going to be called number1 and number2. We'll set this as the number type, and we'll leave the required option checked. This required option allows the user to either be forced to put something into the parameter or allow it to be skipped by the user when they're calling the function. We'll repeat this and create our second parameter called number2. Once we save our function, we can see that it appears in our custom properties. We'll select the function's name so we can see its default value, and you can see right now it's set to 100. We'll remove this and we can define our custom function directly in the formula bar. In this case, we want to add two numbers together, and the two numbers should be our number1 and our number2 parameters. As we start to type number1, you can see it's actually suggested to us in the formula bar. So Power Apps knows that these are parameters inside of our custom property, and it's suggesting them to us to use in our function. Let's now insert a text control into the component, and for the text property, we'll reference our component name .addNumbers. We can see the formula bar is suggesting that we enter number1, which we'll just set as 4. And after entering a comma, it's now asking for number2. Once we close our formula, you can see it is taking our two values and adding them together to display the number 8. Think of formula properties as a way to create your own custom formulas that output exactly what you need them to and allow you to reuse that same code in multiple places in your component. In this case, we could reuse this custom function and call it in many different places to add some numbers together. Now in our example, we chose an input function when we added this property, and the input type is basically that the output of the function is consumed by the component. If we look at a screen, we can see an input property for addNumbers, and we're able to change what exactly that formula does. Instead of adding number 1 and 2, maybe we want this instance of the component to multiply them. I can change that here without changing every component, and the resulting number is displayed inside the component. So in this way, with input functions, our controls inside of the component are really just referencing the placeholder of what that function is going to output. It doesn't exactly know what the function is going to be when inserted on a screen. And that's at our liberty to be able to update and change that, depending on the use case on the screen. It's important to note that we can't access this number that's displayed in the component in our app. Since this is an input function, it's only exposed to the component. If we go back to our component and we change the function property to an output, very similar to our data type, with functions that are set to output, we can output the resulting value of that function to be consumed by something in our app. The next type we'll look at is the actions type. Now we can think of action properties as a way to perform behavior functions inside of the component, which we can then call by something like a button in our app. Our app is triggering these actions to do something inside the component. These are very similar to the function properties that we just looked at, but as I mentioned, these can perform actions like resetting controls or setting variables inside the component or even clearing collections. Let's take a look at an example of this. In this case, we want to create an action property to reset controls inside of our component. There's a dedicated reset property for components, but let's pretend that doesn't exist for a moment. We'll go ahead and insert a text input and a combo box into our component. For our combo box, we'll set the items as sample gallery items, and then we'll move on to creating our custom property. For the name of our custom property, we'll call this reset controls, and you can see that we get very similar options to the function properties for a return data type. If this action was performing something in our component and was expected to respond with information to our app, we could define that here. We can also add parameters just like with the functions, and that would allow us to request input when this action is called. For this example, we'll leave our return data type as none, and we won't add any parameters. We'll select our new reset controls action property, and we'll set a default value. Here we want to use the reset function to reset both of our controls in the component. We'll go back to our screens and we'll insert our action component. You can see that if I enter some values in our two controls, I have no way of clearing them. We'll go ahead and insert a button on the screen and we'll type in the name of our component. After entering a dot, you can see one of the suggestions is our reset controls action. I'll select this and you can see it opens a parenthesis. If I had parameters in my actions, I would be prompted to enter those here. But in this case, since I don't have any, I can just close my parenthesis. When I select this button now, you'll see that the controls inside the component get reset. The action property is being called by the button in our app, and it's performing the actions inside the instance of this component. If I insert another instance of my component and type some values into that one, you can see that our reset button doesn't do anything. Instead, it's only affecting the instance that we're directly calling in the button. To summarize actions, you can think of these properties as a way to trigger PowerFX code that only affects controls inside of your component. This doesn't affect anything in your app, and instead is limited to the instance of your component. Next, we'll talk about events. Now, events are similar to actions in the sense that they can perform behavior formulas, but their use cases are slightly different, and in my opinion, they're more powerful. Event properties are essentially a placeholder to input PowerFX functions on an individual component's instance. A common example of this is actually with the stock button control in Power Apps, where you're given a property called onSelect. In the onSelect property, you can put any number of functions which can modify the behavior of your app. The same goes for the event properties, where you can define a formula in the property and your component can reference that dynamic property to execute whichever formulas you've inserted into that component's instance. Let's take a look at an example. We'll insert a button into our component and we'll just place it in the middle of the component. Next, we'll insert an event custom property called custom onSelect. We have the same options as actions and formulas as far as having a return data type if this is supposed to return something back to the app, but in this case we'll leave this blank. We can also add parameters to the event property, and that allows us to pass in data from our app to then be consumed by the controls in the component. We'll look at an example of this later on, but for now we'll leave those blank and save the property. We can set the default value for the event property, and this is just what will show up when the component is inserted on a screen. We'll have the option to change this per instance of the component, however. So we're really just defining what the default functionality should be before you update the formula on your screen. We'll just set this to the notify function to say that our default property was selected, and we'll see how this looks when we insert the component on the screen. Next, we'll head to our button, and on select of the button, we want to reference our component's name .custom onSelect. Very similar to the action properties, it requires an open parenthesis, and we can input parameters if we had added those to our property. In this case, we'll close our parenthesis, and you can see that our button isn't calling any specific code, it's just triggering the custom property of our component. That way, the code of our custom property can change depending on what screen we've inserted it on or what function we're trying to use it for, and what purpose it's serving in our app. On our screen, we can insert the component, and you can see that our custom onSelect property shows in the Advanced tab of the component's properties. The formula in this is our default formula that we defined in our component, so we'll try this out just by clicking the button in the component. You can see that our app notifies us that the button was pressed. So this button is triggering our custom onSelect's code to run in our app instead of in our component. What if we want to change the formula though? Let's say that when the button gets pressed, we want to do something in our app, such as navigating to a different screen. We can simply change our notify function to the navigate function, and we can enter a screen to navigate to. You can see now that we didn't have to change the button's onSelect property in the component, since it's just calling our event property. The event property is then executing whatever code we put in it when the button triggers. You can think of these properties as a way to have your component trigger PowerFX formulas in your app. This makes components very portable because the formulas are not hard-coded into your component. Instead, they can be swapped out and changed depending on what the use of your component is on the screen. Now let's look at some examples of previous components that we've built on the channel and see what kind of properties we used for those. We'll start with the Fluent Card component, and we can see here that we have many different types of input properties, and these are used to fill the various different components that are inside the cards, like our images, our title, our descriptions, and our buttons. You can also see that we're using an onSelect property, and this is an event type property. This is triggered when the buttons in our toolbar are selected, so that it can trigger an action to happen in the app. In this case, we're using a parameter, and that's called the selected parameter. We can see this is a record type, and it's required. So when a button is pressed in the toolbar, we're actually sending which button was pressed to this custom property. If we go to the toolbar control, we can confirm this by looking at the onSelect property. We can see it's calling our Fluent Card, and it's calling the onSelect property. The parameter that it's passing is the self.selected parameter. One trick that we didn't touch on as far as parameters are concerned is that these have their own default values associated with them. So if we go up to the top left corner of our component and look at our property list, we can see where we have the onSelect property, and indented right below that is our selected parameter. We can see the default value is taking the first record in our action buttons table. And this table is used to build our list of buttons in the toolbar control. For this auto height property, we're using a data output to output a number to our app. And this number is basically telling the app how tall our component should be, based on how tall the controls are in this component. The app wouldn't be able to tell, for example, how tall the component container is unless we output the container's height through our custom property. If we select our height, we can see that the height of the component is set to that auto height property. And if we go to a screen where this is inserted, we can also see the same thing. For our next example, we'll look at the Fluent2 dialog component. Now, this component uses a couple different types of properties, but we've already covered data properties and event properties pretty well, so I'll show you an example of an action property. So in this component, we have a property called setVisibility, and this is an action property. Now, if we look at the default value of this property, we can see that it's setting a variable called var_dialogVisible to the opposite of its current value. Now, the reason we're doing this is to toggle the visibility of the component. So if it's true currently, it'll flip it to false. If it's false, it'll turn it to true. Now, because we have the Access App Scope option turned off, and we also are using an action property, this variable that it's setting is contained to the actual component. You can almost think of it like a local variable that only the component instance can access. Now we're outputting this variable to our app through a different custom property. And this is another output property, but this time it's type data. So for this dialogVisible component property, all this is set to is var_dialogVisible. And that way our app can know what's the status of that variable inside of our component. Should it be visible or should it be invisible? If we go to a screen and we click on our instance of the component, we can then go to the visible property and see that it's set to self.dialogVisible. So again, that's that data output, outputting the resulting variable from our action property. Now, the reason we do this to have an action property inside of the component is that we can keep multiple dialogues separate from each other on a single screen. If we're using a variable to control whether a dialogue is visible or not, and that variable is accessible by the app, all of the dialogues would show up at the same time on one screen. But by disabling Access App Scope and using an action component property, we can control the variable just within the instance of the component. Now, because that's an action property, we can also trigger it from outside of the component. So you can see up here we have a button that's in our app, and this button is simply referencing the Fluent2 dialog that's on the screen here, and it's triggering that action property. So when this is selected, we can see it's toggling the visibility of the component. Now, one last example that we'll look at is the Fluent2 message bar. We can't see the preview here, but in the notify property that we have, this is another action property that has a couple different types of parameters in it. When the app calls this notify action property in something like a button, we're required to put in these parameters. And these are all the parameters that we need in order to perform the default property of this action, which if we look up in our formula bar is the collect function. So we're creating a collection called col messages and basically creating a record from all of those input parameters. This collection is then used in the actual component to fill the controls that are displayed to the user. If we go back to one of our screens, we can see an example of the message bar. Selecting this button in our app, we're referencing this instance of the Fluent 2 message bar on the screen, and we're calling its notify function. And then we're basically just filling out those parameters that we requested in the custom property. When that button is clicked, the collect function is run inside that action property, and it creates this record that's then displayed to the user as a message. Since that access app scope option is disabled, these instances of the component are separate from each other, so they have their own collections stored inside of them. So container level 1 is referencing message bar number 5, whereas the app level button is referencing message bar number 4. And that's about it. There are so many use cases for these custom properties and components, and it's really something that you can start to use in bits and pieces as you're building your components. As you use them more and more, you'll get more creative with them and figure out ways that you can make things more efficient in your components. I hope this video kind of gave you an introduction into how those different properties work, so that when you see them in future videos, you'll understand the reasoning behind why we're using certain properties instead of others. Let me know in the comments what kind of use cases you've had for these custom properties. And if you have any questions, be sure to leave them down there as well. If you enjoyed the video, please consider subscribing to the channel. And again, I hope you enjoyed. Have a great day.